Alright, continue from Lab2 Part 1. This is Lab2 Part 2 video. And in this video, I'm going to show you how to make some of the homework and also emphasize on the quality of sketch. So let's say, maybe let's start from this one with 3 holes. Okay, and I'm going to clean up those. So in X, you can use Windows, basic Windows keys. Like you can hold down Shift and click the bottom one, click the top one, that will multi-select all the features. Right click, and delete them. Right now I have a clean file. So I'm gonna create this geometry, and along the way I'm gonna show you why sketch quality is very important. And now let's start with this. So radius 40, zoom in a little bit. Okay, radius no, diameter 40, diameter 18, then 120 apart. So I'm gonna build a sketch first on XY plane. Alright, now I don't know how big my sketch is, but just simply dropping in one circle first. That'll be the center, diameter 40. So it's pretty big. And zoom in, zoom out, or you can use fit to see everything you have. Now next will be diameter 18. Just type in the number and hit enter first. And once you see the dashed line, drop it. And you can drop it. They're definitely on x-axis now. The only difference is they don't have constraints. You can still move them away from x-axis. Okay. Now for the outside, it's kind of tricky. Don't ever try to use profile tool to draw something like this. This is very tedious. Okay, and the fast way is, if you look at anything like this, for the top and the bottom, you can use fillets. Okay, you can use this fillets. For this side, you can just put 2 circles and trim them off. You can also use fillets, but that's kind of too long for a sharp corner. Okay, so I'm gonna show you the common way. I'll use 2 circles for the side, radius 15. So let's put this diameter 30. That's also 30. And for the top, usually you can just put another circle with radius of 25, like so. Then you can connect them. I guess this is actually a better way to do it. Okay, so you can use straight line to connect this to that. You want to enable point on curve snap. Okay, and sometimes it's very easy to snap to the center of the arc instead of the arc itself. You see the difference? Now it's on the curve. If I move my cursor inside the circle a little bit, that will be the arc center. So 2 ways: disable the arc center, or you can keep your cursor outside of the circle, just a little bit outside. Now if you move a little bit inside, that will be the center of the circle. Okay, so a little bit outside, click. Okay, and now it's tangent. That's good. So I'm gonna move here, and I see that's tangent. That's also good. And wait for this icon says the same as this, point on curve. Click. Well, that quick selection window is because I hovered on the position too long. So I guess that's the third way. Just wait and see this quick pick and pick point on curve from that window. So now also here, point on curve. You can do the same for the bottom. Now it's not tangent anymore, so I have to go back to the circle, then pull out the tangent line. Then wait to see that tangent come out. If it's not coming out, you can just drop it. Well, it came out. If it didn't come out, then you can just drop it, then add the geometric constraints. Okay, so I have the basic shape. I just need some dimensions and the constraints. So first, I'll put this 120 from center of those 2 points. 120, and it's not symmetric, right? So what do? We can put another dimension here, says 60, and okay, we can do that. Okay, click the center of this and click the center of that. You can say 60 or you can say P6 divided by 2. Usually this is better. Sometimes if you want to change P6, right, then P7 will change. Okay, and guarantee you this can move up down. So constraints, we need a geometric constraint to put the center of the arcs, the circles, to x-axis. So we have this constraint on the second. That's point on curve constraint. I don't know why I'm not this it's not showing the name. Anyway, so you want to constrain the object to constrain are the points, the center points of those arcs. Then the object you want to constrain to is obviously the x-axis. Sometimes it's, if the axis is too small, you can zoom in, zoom out to make it bigger or small. And pick the axis, and voila. See, everything is green now, the color. So looks like we have a fully constrained geometry. We'll see later. And for now, it seems like everything is fully constrained. And let's try to move it. Nothing happened. Right. So doesn't look like the practice though. 40, 50. Okay. Okay, we made a mistake. This one should be, well, the bigger one should be 50 in diameter. Then the smaller one would be 40 in diameter. Alright, that's what it should look like. And that's also a nice thing about fully constrained. If it's not fully constrained, sometimes the left side will be different from the right side. So after you fully constrain the geometry, then you change the dimension, the geometry stays reasonable, let's say. Alright, so we can use quick trim command to clean the geometry. Okay, so now that's what we need. Then since we're done and we're going to extrude all the curves on this sketch, you don't have to finish sketch first. You can simply click extrude right away, and the thickness is 20 inch. Okay, that's what we need for this exercise. So let's try this again. Try exercise 2, I guess. Okay, try this exercise 2. And in this, I'm gonna show you some sloppy sketch. Then let's see why you always want to pay attention to sketch. So I'm gonna hide this exercise 3, not deleting them, just hide them, and build another sketch on XY plane. Okay, well it says XZ plane, but you don't have to do. Okay, let's look at the dimensions. So that's the diameter of this cylinder is 80. That means half is 40, then 120, a half is 60, right? So we can start from profile tool, and you can type in the numbers first. So the bottom is 60, and we can type in 60, hit enter. So that's how long 60 is. Then for here, as you can see, it's vertically 12 inch, so it's not the length of this line. I'm gonna just leave this. Okay, get a general shape of the sketch, and look at what I'm doing. I'll overshoot here without hitting this line to pull out. So if I overshoot and I'm here and I just carelessly drop this line, not getting close to the start point of my sketch. Okay, well that's too big. Okay, then maybe like this. Okay, now from far away you think, okay, this loop is closed, right? And try to extrude or try to revolve this. I'm gonna revolve without putting dimensions first. Have everything, then we can specify the vector, maybe this line. Okay, and ta-da, I'm able to create this section. Why? Because you have this little opening here. Let's try to revolve on y-axis, maybe. Okay, it's not doing anything now. Okay, then cancel. So the point is, you want your sketch, most of the time you want the sketch to be a closed loop. This is open loop. Okay, it's not closed. And maybe you can extrude this sketch, but we would say, okay, why my sketch look like this? Because it's not closed. And also, then probably you found this place. You say, okay, I'm gonna close this, right? I'm gonna use a line instead of quick extend, which is recommended, or which is a better way. I'm gonna use this straight line to close here, and without snapping to this point, you just sloppily drop this line here, close this. You say, okay, I'm close to this loop, and let's extrude or revolve. Alright, seems like revolve is very kind. Let's try extrude. Okay, it's better than I thought. Let's try finish sketch and extrude. Alrighty. Well, I would think this will not extrude. What about this? Close this gap. Okay. Because the on curve snap is not always on. By default, it's off. So close this like so. Wow, it's so hard to repeat that. Maybe close like this and extrude. Well, of course it's still open, but okay, let's try another one. Let's say if I have two lines here on top of each other, and finish sketch, and then extrude and pick the line. It's not doing anything now. And say pick every line here. The section is invalid. Now you would see a lot of this if your sketch is not good. That's what I wanted to get actually. Well, input section is invalid. You have two possibilities. One is like here, we have two lines on top of each other. It's not a closed loop because you have overlapping. And the other possibility is like this little gap. But sometimes for the gaps, you can actually extrude them into sheet body. But overlapping is the worst. You will always get this. So you always want to examine your sketch. Okay, something like this. See this? And let's extrude again. Even though let's fix this side first. So let's create a corner. Oh, this command, make a corner. That's like an advanced quick extend. So this is nice and clean and closed, right? Okay, and once you zoom out, you feel like this loop is very good. Then extrude. Man, this is awesome now. Okay. Okay, I think it's this one. Maybe invert curve. I don't know, and the default is maybe invert curve. Okay, that will give you a invalid because of this sticking out. So the sticking out, the gap, overlapping, that's all very terrible, poorly quality sketch. Okay. Of course, you can get away from, I think, this option, regional boundary curve. It will just auto cut off whatever that's on the boundary. But by default, it's on. So it's defaultly it's on invert curve. Then you got errors. So, well, I guess you can be sloppy, then just let computer do their job. Pick this. Okay. Like revolve in this case. Now you can tell there's some problem here. Okay, let's try this. Alright. So anyway, a good quality sketch is always good. It's a lot less problems. Okay, so now let's go back to the sketch. So how to fix this? And if they intersected, you can just quick trim. It's one method. Or if they're a little bit away from each other, like so, you can use make a corner. You can use make a corner. Just click those two lines, it will make you a corner. And if it's not a straight line, if you have an arc, then straight line, you cannot make a corner. Then you need to use more complicated command. Coincident constraints. Then you need to constrain this point to the other point. Then they're coincident. And the big blue dots are coincident constraints. If you look at this, the dot indicates they're coincident. So if you have a quick glance here, see those big dots, that means they're connected. So that's a good thing to look at. Alright, now let's finish this exercise. It's pretty simple, and I'm sure a lot of you can finish this without watching the video now. So 60. And apparently this line is on y-axis, so I'm gonna put collinear constraint this vertical line to y-axis. Now that's nice and clean. And that's another topic about how to position your coordinate system. You have the rotation axis right in the middle. So you want one axis is your rotation axis. If your sketch is like this, it's okay, but it's not very professional looking. Okay, so I'm gonna put this line in the middle, then keep adding dimensions. So some of the tricky dimensions are maybe is 12. Some of you might just click on this line. It's actually able to drop 12 here. If you really have a hard time find this angle, you can click the top line and the bottom line. Then that's your distance between them. And this 117 degrees, you can simply click this line. And there's no vertical line at this position, but you can click this or the x-axis. Right. So that's 170. You can put it here, but then you have to do some calculation. So 117. Then this 77 degrees is from this line to this line. Okay. When you look at the drafting, the arrow is here, but not necessarily. You have to click here because there's nothing there. You can just click on this line. Then that's 77. And bear in mind that this picture is fully constrained once you put in all the dimensions. You probably say, okay, how long is this line? Well, there's no dimension for this. Actually, that's the last section of the dimension loop. Okay, once you put in other dimensions, this line will be defined. So just keep going. That's 30. And you have to be careful about the angle you're pulling out. You want to pull out vertically and horizontally. Sometimes people pull out like this, then put 30, then you got different geometries, dimensions. Okay, so top is 40, then from top to bottom is 150. So 150, then we're getting close to fully constrained. Now from this side to, the diameter is 70 of this cylinder, so half is 35. So that will be 35 inch, and it's not green in this section here. Let's see what we got. We still need this 40 from this point to the rotation axis. So by the way, for this dimension you can click on the point instead of lines. So that's 40. And as you can see, the whole sketch is green. There's no degree of freedom now. So we're fully constrained, as you can see on the top. Now we're good for the homework and for the sketch. So finish sketch, rotate, now revolve, sorry. Click the sketch. You can also pick this line as your axis. There you go for exercise 2. So for Lab 2, the homework requires fully constrained sketch. Okay, different from Lab 1. You only need to get the general shape. So you always need to check, like in the sketch, you always want to check here if it's fully constrained. or over constrained. Okay. So I'm gonna maybe also make this homework 5 or exercise 6. Let's try homework exercise 6. So the idea of exercise 6, okay, on the sketch, is again use quick trim. Use quick trim as much as possible, so you don't have to draw everything on the way. You can combine those basic geometries to get this shape. That will be much faster than you use profile tool and draw an arc here, straight line and arc, straight line arc. That's just too much, too slow. So if you look at this geometry, generally this is a rectangle plus this circle and plus this this opening. So we can just drop a rectangle first, and since it's not symmetric anywhere, I'm just gonna locate my coordinate system at this bottom left corner. So the width is 60 inch, height is 18. 18. Hit enter. That's the size, and you have 4 locations to drop it. Excuse me. Now then I can hit fit, bring in the geometry. Then on the top, that's an arc or a circle, which is on the line. So I have to enable this point on line snap tool. I can put my center on the line, then draw a circle with a diameter of 16 here, and there's 18 away from the left side, so I can use dimension from this point to the left side. That's 18. Okay, and as you can see, everything is green right now. Before you add the dimensions, this circle is not green, right? So that's indicating your circle is fixed constraint. Then let's make this opening here. So here I can use this profile tool, and either you start from the line or you can overshoot, which might be a little bit easier sometimes, and then trim them off. So I'm going to trim this off. Also, you can trim the circle. Okay, and you can leave those fillets to the last. And it's very simple. And for this geometry here, we can just use dimensions. And once you active dimension, you know where you need dimensions. Those places that's green, you don't need the dimensions. So I just need 50 degrees here, and it's not there, but by default, you know it should be symmetric. So I'm gonna add another 50 here. If you don't like to see the numbers, you can put another constraint like equal angle or something like that. Okay, and 2.5 from the bottom of this trench to the surface. So that's 2.5 inch. Then as you can see, the top is constrained on Y direction. Okay. Then the opening is 11 inch. Well, you need to click on the point here, 11. Then lastly, the length of this section is 10. Now everything is fully constrained, if you close this command, the top says sketch is fully constrained. Then we can drop in those two fillets, and you know what? I'm gonna use edge blend instead of fillet. So I'm good in this sketch already. Okay, and I'll just extrude this sketch, probably symmetrically, so you know there's a symmetry on this part. It's symmetrical in the middle, so probably 15. Okay. Now, for those fillets, you can make fillets in the sketch, or you can also use edge blend for the 3D geometry. You can pick this edge, and if they are the same in radius, you can pick them both. Then type in the radius, that's 5 inch. Then you can hit enter to have a review of how big the edge blend will be. Then just click OK. Then you have exercise 6. Alright, I guess that's enough for Lab 2. Okay.